I'm going to be going over how to solve roots of quadratic equations with 3 different methods. You could probably guess that my students are on algebra, or my current recent students are doing algebra. So hopefully this is helpful if you're stuck on this topic. Okay, so the 3 methods you probably have learned are the quadratic method, quadratic formula, factoring, and completing the square. Okay, so I'll go over the procedure for each one of them individually, and then I'll give you guidelines for which one is best to tackle the problem. Because it really depends on the problem and how it's presented. Sometimes one is much faster than another method. And sometimes it's really clear which method is the best. Sometimes it's like a tiebreaker. It doesn't really quite matter which one you use. So I'll go over some guidelines of all that. But I will say that all 3 of them always work. And I'll show you by solving the same problem all 3 ways. So they always work. Okay. Again, it's just a matter of which one's easiest to use. Okay. And just a quick reminder, roots or zeros, I like to call them zeros, I don't really like to call them roots, are when the y value is 0, which in other words, another name is the x-intercept. So we're solving for the x-intercepts. We're solving for the zeros of the function of the quadratic, which means the y value is 0, or we're solving for the roots of the quadratic. Okay, there's different ways to say it. Okay, example 1. So we're going to solve this quadratic in all 3 ways. So we're going to first use the quadratic formula. X squared minus 3x minus 40. What's the quadratic formula? X is negative b plus or minus square root of b squared minus 4ac over 2a. So here, since this is already in standard form, we can pick out a is 1, b is negative 3, c is negative 40. We plug into the formula, that's right here. Ooh, we got to simplify this. This becomes a plus 3. This becomes a positive 9. Yeah, this is 160, positive 160. Yeah, so 160 plus the 9 is 169. Yeah, so bottom is just 2. What's square root of 169? Ooh, do we know this? Hopefully we do. That is 13. This is why I recommend my students to memorize the squares from 0 to 20. So like 0 squared is 0, 1 squared is 1, 2 squared is 4, and then even 11 squared is 121, 12 squared is 144, 13 squared 169, 14 squared 196, so on and so forth, up to 20. Okay, that will help you for things like this. Anyway, so that's 13. So it could be 3 plus 13 over 2, which is 16 over 2, or 3 minus 13 over 2, which is negative 10 over 2. So our answer is x is 8 or x is negative 5. Okay? This is from the quadratic formula. Now, can we factor this guy instead? We can't, because are there 2 numbers that multiply to negative 40 and add to negative 3? Yes, negative 8 and 5. Okay, so we can just factor it as x minus 8, x plus 5. Now we use the zero product property. So if you never understood the zero product property, the concept of it, here is my explanation, okay? So again, we're trying to solve for the zeros of the function, or the x-intercepts, which means y equals 0, okay? That's where the 0 comes from. Now, this is why it's called zero product property. If x minus 8 is equal to 0, okay, so 0 times who cares what this is will be 0, yeah? So if x minus 8 is equal to 0, so if x is equal to 8, we just solve for x. Again, let's check. 8 minus 8 is 0. 8 plus 5 is 13. 0 times 13 is 0. Okay, so when it's a product of things, if one of them is 0, then the whole thing is 0. So that's why we broke it up as x minus 8 is equal to 0. Or x plus 5 can be 0 as well. Yeah, so if we solve for x, that's negative 5. Sorry if you hear the background noise. Negative 5 plus 5 is 0. Negative 5 minus 8 is negative 13. Negative 13 times 0 is 0. Again, if it's a product of things, if one of them is 0, the whole thing is 0. That's the idea of zero product property. Okay. Hopefully that explained it if you never understood it. All right. By the way, same answer, right? 8 and negative 5, 8 and negative 5. So we can complete the square as well. Okay? Again, we're solving for the zeros, meaning the y value is 0. So we're going to set this y equal to 0. Okay? Is a equal to 1? This a over here It is. Remember, that's a big requirement for completing the square. So we can proceed since it is. So x squared minus 3x plus negative 3 over 2 squared. We got to subtract it back right away because otherwise we'll be changing this quadratic. Okay? So we subtract it back right away, and then this minus 40 is still there. And another way to do it is instead of subtracting it back right away, you can just add it to the other side of the equation as well, if you like to think about it like that. Okay? The reason I wrote it like this is because now this term you can just move right into here. It becomes x minus 3 halves squared, and this is minus 9/4, and then minus 40 still, okay? We got to simplify this. So we need a common denominator to be able to subtract these, right? So let's use denominator 4. So we got to multiply the top by 4. That's 160. Does that sound familiar from the quadratic formula? 160 and the 9 becomes a 169, and I moved it to the other side of the equation, by the way. Okay, so 169 over 4 is x minus 3 halves squared. Now we square root both sides, so x minus 3 halves is, don't forget the plus and minus when you're square rooting an unknown. You got to keep your options open, so write the plus and minus. Plus and minus square of 169 over 4, and then we can simplify this radical to 13 over 2, okay? So if we add the 3 halves, this looks really familiar, right? So it should be x is 8 or x is negative 5, just like the other two methods, which it should be matching, because otherwise, why do we learn these three methods that give differing answers, okay? So let's dissect the three methods. Clearly, factoring was the fastest. If we are able to tell that this is factorable, that's the big prerequisite. Otherwise, it's not usually the fastest way to do these types of problems. You factor and then use zero product property. Very easy, typically. Okay. Quadratic formula is always straightforward. It's just a formula, right? You got to pick your A and B and C after you get it to standard form. But the drawback for it is sometimes you end up with big numbers like 169. Do we know the square of 169? I tell my students to memorize it because I told them to memorize 13 squared is 169. So if you know that, great. Quadratic formula is not that bad. But in general, you might have to deal with big numbers. So you need to be comfortable with the big numbers, okay? Completing the square, notice there's a fraction. A lot of people don't like fractions. So you got to be comfortable with working with fractions as well. Okay, as well as the 169 came up over here again as well. Okay, so here's the takeaway from example 1. Always try factoring first. It's typically the easiest. Not always, we'll see in example 3, but typically. That's why it's a guideline. Try factoring first. Not like a procedure, but a guideline, okay? Example 2, x squared plus 4x plus 2. Let's use the quadratic formula. We plug in. I won't go through all the steps. You can pause the video to check. You'll get minus 2 plus the minus square root of 2. Okay? Quadratic formula always works. How about factoring? Can we think of two numbers that multiply to 2 but add to 4? I can't think of any, at least not integer numbers. That's foreshadowing of what I'm going to explain in a bit if you're interested and for maybe more honors students. So I can't think of two integers that multiply to 2 but add to 4. So we just say can't solve via factoring. Okay, so we got to try method 3. So by the way, one more time, am I contradicting myself in the beginning where I said all three methods actually work? I'll show you it's not later on. Okay. We can complete the square as well. This one, again, is A1. Yes, so we can proceed as usual. So 4 divided by 2, we take this term, we divide by 2, and we square it, okay? Subtract it back right away, don't forget that. And this plus 2 remains, okay? These first three terms over here, they factor 2. What's 4 over 2? That's 2, so positive 2. So x plus 2 squared, and then we have a minus 4 plus 2 over here, okay? What's minus 4 plus 2? That's minus 2. Add it to the other side, that becomes positive 2. So square root both sides, so I flipped the two sides as well. X plus 2 is plus or minus square root of 2. So x is minus 2 plus or minus square root of 2. And this, look, matches over here, quadratic formula. So in this case, it looks like quadratic formula is probably a little easier, but completing the square was not too bad either. Okay. Let's observe Let's dissect this again. Factoring was not doable. So remember my first guideline? Always check if it's factorable first. In this case, it wasn't at least two nice integer numbers. Okay. In this case, again, quadratic form was probably the easiest, but completed square was not too bad either. So here's the guideline for you. When it's not factorable, of course, you got to try one of the other two methods. And if that a is small, then I would recommend the quadratic formula most of the cases. Okay. So here's the bonus slide if you're curious and for more advanced students. As I was saying, all three methods work because actually all quadratics can be factored. They're just not nice integer factors, as I was alluding to earlier. Okay? So from the other two methods, we found that the roots are, or the zeros, are -2 plus root 2 and -2 minus root 2. Okay? These are the two factors, actually. So what if we write them as factors? So this is how we write them as factors. X minus the first factor, X minus the second factor, okay? So now let's expand everything out and we'll see that we actually get back the original guy. So it's just tedious math here, but follow with me. We got to follow this out first. So x squared minus x times -2 minus root 2. And then we have a minus x minus 2 plus root 2. And then this times this over here. Okay? Now let's distribute this x into these two and this x to these two. That's right here. And then let's expand this. This is actually a difference of two squares. Okay? So it will be just -2 squared minus rad 2 squared, root 2 squared. Okay? Remember this formula, the difference of two squares? Okay? Now look, minus x root 2 plus x root 2, those go to 0. We can combine these two x's to a 4x. And this over here, what does this become? This becomes a +4. This becomes just a 2, right? So 4 minus 2. And then that simplifies to x squared plus 4x plus 2. So this is proof that all quadratics can always be factored. It's just not a nice integer factor, so we couldn't do it in our head easily. If you're a genius, then you can think of the factors in radicals, great. That will definitely be faster than doing the quadratic formula or completing the square. But I'm a typical person. I don't think like that. I'm not a major genius, so I would not think to factor like this, even though it is factorable, as I just showed you here. Okay. Third example. We're giving it in this form now. We're actually giving it in vertex form. There's a reason I chose this example, okay? So to use the quadratic formula, we got to first go to standard form. We got to pick out the A, B, and C, right? That's in standard form. So we got to expand this and simplify. If you do the math, it's -2x squared plus 4x. So A is -2, B is 4, C is 0. Plug into the quadratic formula, you get x is 0 or x is 2. I won't go through the steps. You can pause the video to check, okay? Can we factor? We actually could, but the prerequisite is we got to probably, at least how I factor it, I need to see it in standard form first. So we still got to expand it to standard form first. And then I see that, oh, these two have a GCF, greatest common factor of -2x. So I factor that out. And then by zero product property, I can get x is 0, x is 2. Okay, so totally factorable, but you first have to go to standard form. But again, factoring is easier than quadratic formula. Okay. Actually, in this case, it might be fastest to complete the square because this is already the perfect square right here. The square has been completed. Okay. So we don't have to do all those algebraic hacks to complete the square. It's already done for us, so we can just solve for x. Okay, so set y equal to 0, and then we can add this term on this side. Okay, that's what I did. Or you can subtract the 2 on that side. It doesn't matter. Okay. Divide by 2, and then we square root both sides. So x minus 1 is plus and minus 1. So x is 0 or x is 2. Okay, so here is a case where completing the square is probably the fastest. So let's write this down. Okay. Quadratic formula took the longest because you needed to first go to standard form, then use the formula. Okay. Then use for formula, the formula. Factoring was easy, right? But the prerequisite was we still had to go to standard form first, which didn't take long, but you still had to do that and take a few extra seconds. Okay. Complete the square is the quickest in this case since it was already in vertex form. So the key takeaway here is if it's already in vertex form, completing the square is likely the fastest. So honestly, a lot of students think that why would I ever need to complete the square? Here's a realistic case where if the question given to you is already in a completed square form, just um, I guess this, to be precise, you didn't have to complete the square here. It's already done for you. So you could solve it like this. Okay, you skipped the completing the square steps, I should say. So in terms of total steps, this was probably fastest. Okay. Although, as an experienced person, I would argue that this should be 3B, by the way, and that's 3C. I'm catching all these errors now. Sorry about that. I would argue that I would probably do it like this, even though as I guess as someone that's done this a lot, I can do quick expansions like this in my head. So I would still go with the method of factoring. I would pay the price by um, expanding it out in my head, which could be prone to error, but I'll pay the price and still factor because I like that method better than completing the square. I'll be honest. But here's an example where um, yeah, you didn't have to factor. And the quote unquote completing the square method, even though you didn't have to do it here, is likely the best way to do it. All right, so again, this just goes to show that here are just some guidelines from my experience doing the problems myself and my experience helping other students. Some guidelines to choose which method to use. Of course, if your teacher requires you to use a certain method on the test or quiz or whatever, or an assignment, then you got to do it. So that's why I went through all three methods so that you see how to do them in all three methods. But if you're just given a random one on an exam and your teacher didn't specify which method to use, then you got to start thinking critically as to which one is the fastest. Or I guess you don't have to, but it's good to think which one's the fastest so as to not spend 5 minutes using the quadratic formula when you could have just you could have just factored it in 1 or 2 minutes. Okay, hopefully this was helpful. And if you're interested in more algebra videos like this, please leave a comment and let me know what topics you're interested in.